Unit 1, the alphabet and grammar of geometry. Preview video 1.1, Algebra Review and Radicals. Sit up tall. Ready? Inhale. Hold for 3. Exhale 5. Close your eyes. Ready? Inhale. Hold. Exhale 5. Your eyes are still closed. Ready? In through the nose. Hold for 3. Exhale 5. Sit there quietly with your eyes closed. Deep breath. Smile. All right, let's do this. Taking a look here at your preview notes. We are going to be reviewing radicals. Don't forget date, time, location, parent sign off. Okay, focused attention equals faster work. Please turn off all distractions and multitasking. All right, you're going to do a quick review on your own. Get your pencil out. Do this page on your own. Pause the video. All right, students, welcome back. Hopefully you did this on your own. You now have your red pen, and you may turn it to double time. You may correct in double time since you're just correcting. Star smiley if you're correct. And if you're not correct, I expect a note on how to do it differently next time. All right, so we had here 44.30 and 5.20. Had to add the zeros here. And then we multiply straight across. 0 times 5, 0, 0, 15, 20, and 20 again. And 0 times 2 is 0, 0, 0, 6, 0, 8, 0, 8. And this is 0 all the way across. 0. Obviously. All right. And so now we add this first one. That's 0. That's 6. That's 13. Carry the 1. That's 2. That's 10. Carry the 1. That is 3. And then 2. And then you find your decimal. Come down here. And your decimal is going to be right there. Some of you, you're skeptical. You're like, I don't think that's right. Take a look. Of course, because you believe the calculator is somehow God's infallible voice. It's not. But here we go. Okay. We have 44.3 times 5.2. And it's 230.36. All righty. That is a recap of our previous lesson. So for this geometry class, there are 3 essential skills from a previous math class that you should already have mastered. Those 3 skills are computational math with fractions, solving with variables, and lattice multiplication. Your 4th skill essential for this class is to add and subtract, multiply, simplify, and divide radicals. Radicals meaning square roots. Now, I'm going to do a quick recap. What is a square and a square root to begin with? Just in case those are new terminologies. Okay, let's say you have a square. 4 right angles, 4 equal sides, and this edge length is 5 centimeters. If I asked you to find the area Area of a square is the sides squared. So it is 5 times 5, which is 5 squared, of course, which is 25. Now, let's say you had to work backwards. Let's say I told you that the area was 25 centimeters squared, and I asked, what is the singular side length? So side squared equals 25. To solve, use square root. Square root is the opposite. So our side length would be 5 cm. That is an example of squaring and square rooting. That should be a review. So we are going to simplify a radical. And part 1 to simplifying a radical is to factor the radical. I'm going to show you 2 methods to factor. One using a factor tree, the other using what's called ladder division. So the factor tree looks like this. You simply first choose 2 factors that go into a number. If it's even, start with 2. If it's not even, you can check 3, 5, 7, and 13. But since it's even, I'm just going to start with 2. So 2 and D4. And keep going down. 2 and 27. Now 2 no longer goes into 27, but I know 3 does. 3 and 9. You keep going until you get nothing but prime numbers. So these are the branches. You understand what I mean by branches? They branch off. These are the leaves, the prime numbers. You only look at the prime number leaves, quote unquote. Here again is another storyline, is if you have a date, a double, then you get to go out. But when you go out on a date, the word couple is singular. If you see someone step into prom, a nice guy and gal dressed up, and you go, oh, there is a cute couple, a cute couple. It's singular. Let me show you what I mean. So we're looking for dates, and we have dates, quote unquote. And we have a pair of 2s in a circle and a pair of 3s. And they're going to go out as a single couple. There's a 2 and a 3. This 3 has no date, stays home, under the radical sign, orders Uber Eats. Your final step here, 2 times 3 is 6, root 3. Therefore, the simplified version of root or radical 108 is 6 root 3. Here is factoring by what's called ladder division. I'm going to start with 108, and I'm going to divide this way. I'm going to divide by 2. I get 54. Divide by 2 again. I get 27. 27 is not divisible by 2, but it is by 3, 9, 3, 3. That's called ladder division. Again, you're looking only at the outside prime numbers. We have a date. 2 and 2, that's a 2, a 3 and 3, a 3. Stays home, no date. And again, 6 root 3 is your final answer. So that's both versions. You can use either method. Okay, here we have what's called a coefficient on the outside, and then we're going to simplify the inside. Again, you choose your dates. We have a double of 3s. The 3s come out as a single couple. Since there's a coefficient on the outside, those multiply to start with. That's 15. And then both of these persons, they stay home. They go over to each other's house. They have a home party or order Uber Eats, and it's 15 root 6. You did this ladder style, it would look like this. We have 54, 2, 27, 3, 9, 3, 3's come out, times the 5, that's 15 root 6. That is called simplifying a radical. This page, do by yourself, work in pencil, pause. Welcome back. You should have your red pen. Hit double time for corrections. If you're correct, star smiley. If you're not correct, I expect you to redo the problem with a note. What are you going to remember next time? I'm going to do one in factoring and one in ladder. So that's not divisible by 2, but it is divisible by 3. 3 goes in there 21 times. 3 goes in there 7 times. I have a date. Date comes out. 3 root 7 is the correct answer. Here on the right, I'm going to do ladder. I have 240, 2 and 120, 2, 60, 2, 30, 2, 15, 3, 5. I have nothing but prime numbers on the outside. I find my dates. Pair of 2's come out. Pair of another 2's come out. The 3 and the 5 stay home. 15. Correct answer is 4 root 15. Star smiley if you're correct. If you're not correct, redo the problem with a note. What do you want to remember? That's simplifying radicals. Now we're going to add and subtract radicals. What's super easy about adding and subtracting radicals is they follow the exact same rules as variables. Adding and subtracting radicals follow the exact same rules as variables. So let's start by adding and subtracting these variables. So we have here negative 7z plus 3x plus 8y minus 2x minus 5y plus z. You know, when you add and subtract with variables, you simply add like variables. So for example, I have my z's. Negative 7z plus 1z is going to be 6z. Then I have 3x minus 2x. That's going to be positive 1x. Then I have 8y minus 5y. That's 3y, positive 3y. Now, you're done with that expression. Why? Because the z and the x and the y do not collect. So look very carefully here. We have negative 7 root 2 plus 3 root 5 plus 8 root 3 minus 2 root 5 minus 5 root 3 plus root 2. I collect like radicals, just like I collect like terms. So I'm going to collect the root 2's. There's technically a 1 there. So negative 7 root 2 plus 1 root 2 is negative 6 root 2. That should have been negative 6 up there. The roots do not change. The roots are like the variables. So 3 root 5 minus 2 root 5, that's 3 minus 2, that's 1. Just like that x doesn't change, neither does that 5 root 5. Plus 8 root 3 minus 5 root 3, that's 8 minus 5, and that's going to be 3 root 3. Just like that y doesn't change, neither does the root 3, and it is positive. And you are done, because just like you can't collect unlike variables, you cannot collect unlike radicals. Now, for this problem, it actually has 2 layers. Before I can add and subtract, I must simplify. notice there are things down here that can be simplified. So the way I'm going to do that is I'm going to first simplify and then add and subtract. So start factoring every single problem. So I factor tree all of them. You could also do that upside down ladder. It doesn't matter. And now I'm going to take out my date. I have a date of 2's. They come out as a single 2. So that's going to be, don't drop your negative there, -2 root 5. Pair of 3's come out as an individual 3. 3 times 3. That's, careful with that negative sign, 9 root 2. Nothing comes out. So it's -3 root 5. The 3 comes out. It's 3 times 2. That's +6 root 5. Now, you collect like kinds. I have root 5 here, root 5 here, root 5 here. So I collect -2 root 5 minus 3 root 5 is -5 root 5 plus 6 root 5. That is 1 root 5. I only have 1 root 2 minus 9 root 2, and you are done. You could write it like this if you wanted to. -9 root 2 plus root 5. Both of those would be correct. All right, time to practice. Remember, it's okay to be wrong, but it's not okay to be passive. I don't want you copying the answers. Do your work in pencil, pause. Welcome back. Should now have your red pen. Hit double time. You can do double time through the corrections because you're just correcting. If you're correct, star smiley, woohoo, some sort of I'm so amazing marking. If you're not correct, I want to note, what do you want to remember? Here we go. You should have factored all of them. All right, this first one, no date comes out, stays the same, -2 root 5. 3 came out, 3, that's -9 root 2. Nothing comes out, plus 3 root 2. 2's come out, plus 4 root 5. You collect like kinds, root 5, root 5. That's -2 plus 4, that's +2 root 5. That's -9 plus 3, that's -6 root 2. Or you could have written it like this, -6 root 2 plus 2 root 5. Check your work. Okay, so we simplified radicals. Then we added and subtracted radicals. Now we're going to multiply and divide. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. I gesture, you gesture. Outies, innies, simplify. Outies, innies, simplify. Let me show you what I mean by outies, innies, simplify. When you're multiplying radicals, you multiply the outies. 3 times 7. You multiply the innies. 3 times 6, but that's under the radical sign. And then you simplify. Outies, innies, simplify. So the simplify looks like this. I go to the radical sign. I'm going to factor both of these. I have a 1 and a 3, and I have a 3 and a 2. So I look at both of these, and I have a pair of 3s between them, and when they come out, they come out. When the date goes out, it goes out as a couple, which is singular. So 3 times 3, 9 times 7, it's 63, root 2. Ta-da! You're done. Outies, innies, simplify. You try this one on your own. Pencil, pause. Welcome back. For corrections, you can go to double time. Outies, innies, simplify. Outies, innies, simplify. It's 1, 5, 3, 5. I have a date of 5s. They come out. So 5 times 7 is 35, times 2 is 70. Root, who stays home, no date, 3. You're done. Outies, innies, simplify. Dividing follows the same process, except instead of multiplying, you're dividing. Outies, innies, simplify. Okay, so we have here 24 root 15 and 4 root 21. We are going to first divide the outies. So when I divide the outies, 4 and 6 reduces. 4 goes into 6, 6 times. I'm going to keep that 1 just so you can see it. 1. Innies. I have a 15 and a 21. Now, 15 doesn't go directly into 21, but both are divisible by 3. So we are going to end up with 3. 15 divided by 3 is 5. And 21 divided by 3 is 7. Those are still under the radical sign. Now, you simplify the outies, multiply, divide, simplify the innies. Now, simplify. When you simplify radicals with division, the main rule is you cannot leave a radical in the denominator of a fraction. And the way you get that out is you multiply top and bottom, numerator and denominator, by the exact same radical. Let me show you why. So I'm going to multiply the top by root 7 and the bottom by root 7. So at the top, I have now 6 root 35 over root 49. One more step. Well, root 49 is perfect. Remember, you don't want any radicals in the denominator. So I have 6 root 35 over root 49 is simply 7. Last thing is you check to see if you can simplify the outies. Again, 6 and 7, you can't, you're done. You check here to see if there's any dates that can come out. All right, and we have 5 and 7. There's no dates there that you can bring out. So your final answer is 6 root 35 over 7. Outies, innies, simplify. All righty, friends, get out your red pens, hit double time while you're correcting. That's fine. Outies, innies, simplify. So outies first. 6 goes into 42 7 times. So we have a 7 and a 1. Innies, 4 goes into 32 8 times. 4 goes into 12 3 times. So your final version looks like this. Okay, so there's your outies and there's your innies. Now you simplify. So we're going to multiply top and bottom by root 3 to get rid of that radical there. So what we end up with here is square root of 24 over 7 times square root of 9. We're going to factor this. I'm going to go sideways to make it easy. And that's 4 times 6, or 8 times 3, same thing. 2 and 2, 2 and 3. And we have a pair of dates, which is a 2. 2 is going to come out. So I have 2 on the outside. Root 6 over 7, and square root of 9 is 3. I check my outies to see if you can reduce any more. I have a 2, a 7, and a 3. There's nothing else you can do. So it's 2 root 6 over 21, and you are done. Now I'm going to show you some shortcuts. Really important radical shortcuts. Ready? Here we go. Root 2 times root 2. Innies, talk to innies. Technically, that's square root of 4, right? 2 times 2, square root of 4. But square root of 4 is a perfect square. So it just becomes 2. Watch that again. Root 7 times root 7 is root 49. But root 49 is perfect. It's just 7. So now I want you to use this shortcut. I want you to get rid of this middle step for both of these. And this is the primary shortcut I want you to see. Any radical times itself is just the number on the inside. So root 2 times root 2 is 2. Voila. Root 7 times root 7 is 7. Done. There's your shortcut. Let's try this. Square root of 5 squared looks like this. Root 5 times root 5. But you know, technically root 5 times root 5 is just the number on the inside. So it's just, ta-da, 5. Root 17 squared looks like this. Root 17 times root 17. Any radical times itself is just the number on the inside. 17. Now life's going to get a little interesting. 3 root 2 times root 2. First, you do the radicals. Root 2 times root 2 comes down to a 2. 3 times 2 is 6. Wow, how easy is that? 6 root 5 times something is 30? I mean, you know in your head, this is kind of what you're thinking. I know 6 times 5 is 30, but the problem is I have a radical there. So how do I get rid of that radical? Well, I know root 5 times another root 5 is just a 5. So I need another root 5 here. Watch. Root 5 times root 5 just gives me 5. 6 times 5 is 30. Therefore, 6 root 5 times root 5 is 30. How simple is that? Ready? Oh, monster. Wait a minute. What's up with this? When you can't instantly think of the answer, you ask yourself this question. Well, not what should I do to figure out the answer, but, well, what can I do? And you kind of just whack at it piece by piece. And I'll show you the reasoning behind it, okay? You're like, I don't know what, 7 and 2, and it's not like the other one, 6 root 5 times root 5. Okay, but you know you need another root 2. I mean, you know at least that, because that's the only way you can get a radical. Rid of that radical, because root 2 times root 2 is 2. You know somehow you need a 7 there, somewhere. So I'm going to put a 7 there. Now, look at what you have so far. 7, I'm going to do this in the margin. 7 root 2 times root 2. Technically, that's 7 times 2, which is 14. Ask yourself, how could I get a 14 back down to 7? Well, I can divide by 2. So what times root 2 is 7 is 7 root 2 over 2. Why? Because root 2 times root 2 is 2. 2's cancel. What's left is 7. So your complete answer in the gray box is 7 root 2 over 2. Ready? You practice these shortcuts on your own. Pause the video. Get out your red pen and get ready to correct. Put this on double time if you'd like. I'm just going to give the answers. I'm not going to explain them. Root 5 times root 5 is 5. 2 root 3 times root 3 is 6. Root 15 times root 15 is 15. 3 root 2 times 3 root 2, excuse me. Root 3 times root 3 is 3. Root 21 times root 21 is 21. 5 root 6 times root 6 is 30. 9 root 3 times another root 3 is 27. Here I need a root 3, a 4 over 3. Why? Because root 3 times root 3 is 3. 4 times 3 is 12. 12 divided by 3 is 4. Check. You summarize on your own using your own words, complete sentences. What are the key ideas you want to remember? This is called metacognition, thinking about your thinking. Write it down.